Welcome back to linear algebra. Let's jump into Anki. All right, 4 flashcards. What do we got? What is an invertible matrix, and what is another name for such a matrix? Another name for it is non-singular. It's an invertible matrix is a matrix that exists in which another matrix exists. An invertible matrix is a square matrix in which another matrix, in which it commutes with another matrix, and their product is I, the identity matrix. Good. If your linear system has infinitely many solutions, what is a general solution of that system? The general solution is a set of parametric equations in which all solutions can be found by plugging in values for the parameters. Assigning numerical values to the parameters is good enough. If A is a square matrix and n is a non-negative integer, what does the symbol A to the n denote? A to the 0 is going to denote an I matrix identity. A to n equals A times A times A n times. If it was greater than 0. If A, B, and C are matrices for which AB equals AC, and if A doesn't equal 0, does it follow that B equals C? No. Not for matrices. What is this rule called? The cancellation rule. It doesn't really apply. Doesn't always apply to matrices. Cancellation law doesn't hold in general for matrix multiplication. Okay. Good. So, all right. Yesterday we finished the first pass of 1.6 questions. So we're just going to start 1.7 today. So I'm going to go and start reading the chapter, and I'll be back to recall what I learned in a little bit. All right, I actually went back and graded these 2 problems from yesterday. I forgot we had to grade them, but got them both right. So now I'm going to start reading the chapter. Okay, we just started this chapter on diagonal, triangular, and symmetric matrices. So we got through diagonal matrices. Diagonal matrices are square matrices in which all of the entries that are not in the main diagonal are equal to 0. Pretty simple. The main diagonal can be whatever. It can be zeros and still is a diagonal matrix. Triangular matrix is basically a matrix that's either upper triangular or lower triangular. Either of these it's considered a triangular matrix. An upper triangular matrix is a square matrix in which all the entries below the main diagonal are 0. And a lower triangular matrix is a square matrix in which all the entries above the main diagonal are 0. So a diagonal matrix, for example, is both an upper and a lower triangular matrix. So some properties about triangular matrices are that the transpose of an upper triangular matrix is a lower triangular matrix, and vice versa. The product of 2 upper triangular matrices is an upper triangular matrix. The product of 2 lower triangular matrices is a lower triangular matrix. Okay, let's go back. There's 2 more properties, but I just remember some other stuff I forgot to recall about diagonal matrices. So we talked about what diagonal matrix is. A diagonal matrix is invertible if and only if all of the entries in the main diagonal are non-zero. If they are non-zero, then the inverse is basically 1 over the original entry in each of the entries of the main diagonal. A matrix is, or a diagonal matrix, the power of a diagonal matrix, basically if it's a positive power, I think it would work either way. But you can find the inverse first if it's negative. So if it's the matrix to a power, it's going to be each of the main diagonal to that same power, simply. right? Multiply, and then we talked about multiplying another matrix by a diagonal matrix. If you multiply, if the diagonal matrix is on the left, basically you can just take the other matrix and multiply the top row by the top row, the top entry of it basically the entry in 1 1. You multiply each of the entries in the second matrix by the entry that's in 1 1. The second row would be what's in 2 2. The third row was in 3 3 all the way through, etc. And if the diagonal matrix is on the right side, it's very similar except it's gonna be on a row. So the first row of the other matrix is not the diagonal matrix, is all each going to just be multiplied by basically D1. The second column is going to be each multiplied by D2, etc. Okay, properties of triangular matrices. So we talked about the transpose, we talked about the products. Triangular matrix is only invertible if and only if all the entries in the main diagonal are non-zero. There's something else, but I forget it now. Okay, diagonal matrices, what they are, inverse, power, multiplying by them. Square matrices in which all entries off of the main diagonal are zero, good. Invertible if and only if the entries in the main diagonal are non-zero, good. Power, if power is positive, entry is simply raised to that power, good. Multiplying by diagonal matrix on left versus right, left row, right column, good. Triangular matrix, what they are, subtypes, so square matrices, either upper triangular or lower triangular, upper triangular, all the entries below the main diagonal are zero, lower matrix, all entries above the main diagonal are zero, okay. Transpose, vice versa. Product of two, good. Triangular matrix, good. Inverse of invertible lower matrix. Okay, that's the one I forgot. The inverse of an invertible lower triangular matrix is lower triangular matrix. Or the inverse of an invertible upper triangular matrix is another upper triangular matrix. Okay. So that's a good progress today. Really shredding through this chapter. There's a good chance we finish tomorrow. Yeah, if we have the same pace to tomorrow as we did today, we'll finish this chapter tomorrow. So pretty cool. Or that section. That's it for today. Talk to you tomorrow. See you.